Okay, in this video, we're going to go through the introduction to Chapter 2, and we're going to review a bit about functions and basic graphing. So I'm referring to the textbook, so I want you to get in the habit of going in and reading some things from the textbook, okay? So here on page 148, you could find this definition. So let me write it down here for you. So a function, okay? So a function, and I'm going to abbreviate function FCN, is a rule that assigns to each element I'm going to call that element X in a set A, so this is math language, exactly one element called f of x, or y, in a set B. Okay, so that's math language, so you have to understand this. So what's it telling you in a nutshell? In a nutshell, if you have one x and you plug it into your function, you will get out only one y. If you get out two y's, that means that you don't have a function, you have a relation. Okay? We talked about how to test for this in previous classes. We'll go over that again, but for right now, just know what the function definition is. In terms of other vocab here, domain and range, so you should already know that domain are going to be your x values, and these are independent, okay? They're the ones that drive the train. They drive the function train. And then you have your y values, which are dependent. And they're dependent on x for its very life. Okay, so we're not going to ask that definition or any of those definitions on this upcoming quiz, but it's good background information as we study further. Okay, after reading examples 1 and 2 on page 150, here again, we're taking you back to the textbook, complete the following problems. So for this function, f of x, I want you to describe the function in words. So in words, to get f of x is going to equal the square root of x minus 1. So to get your y, you're going to take 1 away from whatever the x value you have, and then take the square root of the remaining value. Okay, and they talk about drawing a machine. So any book you ever see that talks about functions will always have a little function machine. An approximation of that looks like this. Okay, here's my little function. My x comes in, something happens to it, and out comes the f of x. So here is your input. Here is your 1 output. Okay, and this right here is function notation. So instead of calling it y, I am telling you that it is explicitly a function of x. Okay, when you evaluate, you take the number behind the parens, that replaces your x, and plug it in for every x. So basically for each of these, if you have a function, you're going to replace the x by 5, and your result is going to be a number. Okay, f of 122, you're going to evaluate the function where x equals 122. So you're basically going to replace the x by 122 and then solve for the function value. 26 over 25, you're going to replace the x by the 26 over 25 and get me a value for the function. Okay, so that's what we mean by evaluate. So that's an evaluate. Just get this and get that. And I'm going to highlight that word evaluate. So when you're asked in the future to evaluate, That's what you're going to do. We're not going to ask you to do that on this quiz. Okay, piecewise functions. There's an example on page 151, and after you look at that, you should be able to figure out how piecewise functions work. We're going to spend a lot more time on piecewise functions. This is just kind of an overview. So what makes piecewise functions? And what makes it is the domain restrictions. Okay, you have one function. That function is your g of x, but it has two pieces. So here's the first piece, and here's the second piece, but it's all one function. Okay, so what we're going to do is we're going to demonstrate how you evaluate it given you have domain restrictions. So maybe I will undo these colors, and maybe I'll make them, I know what I'll do. I will come over here, and I'm going to make this a blue, and I'm going to make this a red. So now I'm going to go down before I even evaluate any of these x values. I'm going to figure out which piece of the function I'm going to use. Okay, if your x is -3, that falls under the first piece of the function, where x is less than or equal to 2. Okay, 0 falls under that, and 2 falls under that, because it says x has to be less than or equal to 2. The only time you're going to use the second piece in this situation is when you evaluate 5. So you're just going to go ahead and plug it in, and it's really easy for the first several, because what's going to happen? No matter what your x is, your y is always 5. Okay, only in the last case, the red case, you get a different number depending on what your x is. So you're going to take your x and you're going to plug it in here. Okay, so 2 times 5 is 10, minus 3 gives me a 7. So that means that if I were to plot that for an x value of 5, I would get a 7. But for an x value of -3, 2, or 0, I would get a 5. So it's going to be a horizontal line, isn't it? Okay, next thing to talk about with these kind of functions. We're going to do a lot more work on it. We're going to be graphing them. You're going to be evaluating the different pieces of it, but we'll not be doing it on the quiz. Okay, so this is not explicitly on the quiz. But you want to know it as background because we're going to be dealing with it going forward. Okay, this is huge on the quiz. Okay, so I'm going to say, yep, that is on the quiz, and you want to absolutely know that. Okay, so I'm going to make some changes down here. You can read this. I'm not going to read it to you. We're going to have our end result be interval notation. So this is interval notation. That's what we want. Okay, so I might give you it in a set description, or I might give it to you in a graph, and your job is to turn that into interval notation. Okay, hugely important going forward in math, and very important on this upcoming quiz. Okay, so look what we have here. The first set description, what I'm seeing here, is that I have strict inequalities. Strict inequalities mean I have open circles. My function cannot equal those values, and I have parens, which indicate I get close to A and B, but I never equal B or A. Look at the next example. I have an equality symbol there. That means I have a closed circle over here, and I have to have brackets. So the second you see the equal sign underneath the inequality, that sign, that little straight line, looks like the bottom of a bracket. So think about that. Make that association. Okay, the next one, you can have mixed results. So look what we have. We have a paren here. That means I had an inequality here, a strict inequality, and I had an open circle there. But for the A, I have a bracket, So I must have had this, and I must have had a filled in circle. Okay, we flipped it the other way for the next one. Here's your paren. That's what you would give me if I either gave you this or showed you that. All right, but look at the other side. You would give me the bracket if I either gave you that or showed you that. Okay, now the next two I'm going to change because I don't like when you have x on the right side. So I'm going to read this backwards. This is x is greater than a, and this is x is greater than or equal to a. See if you can always have your variable on the left side. It'll help you be more consistent. Okay, for these four, I find these are problems for many students. So don't be that student. So let's see if we can figure it out this time. It says a is less than x. Okay, so, excuse me, it says x is greater than a. That means that I'm going to start my interval at a and keep going bigger. Okay? The next one says x is greater than or equal to a. I'm going to start at a and keep getting bigger. This starts at a, this starts at a. Now let's look at the parens versus the brackets. If I have a paren, it means that I start very close to a, but I can never actually equal it, and that's why I have the open circle on the graph. For the next one, I have a bracket. Well, you should give me a bracket because you saw that I could equal a, and that's why I have a filled in circle over here. Okay, two more to do. So look at the wording for the next two. So let me grab this color. Okay, so now I'm dealing with b. Okay, and the variable's on the left, so that's good. X is less than b. So that means that b, well, close to b is as high as it can get. That's why b is where it is. Look over here. X is less than or equal to b. There you go. That's your endpoint. Here's your endpoint. Here's your endpoint. Okay, try to understand that, and so you know what your triggers are for the order in which you put your A's and B's in this situation. Again, oh, I should mention, you will always, forever and ever, have a paren when you have an infinity. Infinity is a concept. You never actually get there, so therefore you never actually equal it. It has to have a paren when dealing with interval notation. Here's my paren. Here's my other paren because I have a strict inequality and I have an open circle. Here's my bracket because I don't have a strict inequality and I have a closed circle. Okay, last one here. This is a set of all real numbers, which comes about a lot. And you can either write this out if you're in set description, or you can use that fancy R. But in an interval notation, it tells you that you're going from negative infinity to infinity. And that's why I have just a straight line with arrowheads on both ends, because it's never ending. And at the end of all these arrowheads is infinity. Okay, so negative infinity to positive infinity. Oh, and I should say also for interval notation, we always read it from the left to the right. So your lowest values are first, your highest values are last. Okay, so then we talk more about this. A closed diagonal line represents equality. Okay, we've gone over that. Closed is equality. Open is inequality. So equality means that you're going to have either a straight up equals or a less than or equals, a greater than or equals, or just a straight up equals. Inequality, you're going to have either less than or greater than. Or I guess you can even have this, okay? An arrow indicates movement towards positive or negative infinity. Okay, we talked about that. And I gave you the example up above. Okay, this is another big piece that students frequently have difficulty with, and it's on the quiz. So this entire page is going to be really important for your quiz. Okay, so if I tell you that x can't equal this, that's set notation. You need to tell me what x can equal. So it's going to equal all of this up to, but not including, the 1, thus the open circle. And then it's going to jump over the 1 and continue to infinity. Okay, so look at your interval notation. What do we see? Well, we have these parens on either side because I can't equal the 1. It's the only thing I can't equal. Then you have this u, which is a union operator, and that unites our two separate intervals. Okay, so you've got two intervals. Oops, sorry. So you have, this is interval 1 you want, and here is interval number 2. Now there's one observation I want to make. If you omit one value for x, then you have two intervals on either side of the union symbol. If instead you eliminate two values, you're going to have three intervals. So it's always one more interval than the values. So look at these intervals. What's happening is I'm going from negative infinity up to, but not including 2. Thus the paren. You always have a paren here. Remember, you always want to read from the left to the right. Then I have my union. I jump across 2, which I could not equal. And what happens? I then can equal very close to 2, so I use a paren, and I can go to 4 up to right before 4, so 3.99999. And I indicate that by putting a paren. Then I have my union, jump across the 4, start at 4.00000001, and go all the way to infinity. Okay, so the two values that I cannot have are positive 2 and positive 4. And here they are, denoted by open circles on my number line. Okay? All right, so that's important for the quiz. Make sure you understand all of this. Make sure if I give you a graph or set description, you can give me interval notation correctly. Okay, if I eliminate 1 or 2 values of x, make sure you understand how to use that union operator and can set it up just like I've shown you here. Again, the textbook is a good source for other examples. Okay, so in this chapter, we're going to focus on graphing. So that's going to be our big focus. So since we're going to focus on graphing, you cannot graph imaginary numbers, so therefore we will not have any imaginary or complex numbers. Okay, so all of our input or independent variables are limited in these two ways. They have to be real, and therefore they have to cause the value of the output to be real. Everything's real, everything's plottable. Here's another source. After reading page 153 and looking at example 8, complete the following problem. Find the domain, that's the x values of each function below. Express your answer in interval notation. Okay, so I'm not going to ask you this explicitly, but I am going to ask you to give me interval notation. So let's set this up. When I look at my first problem, that is a rational function. Rational functions have ratios or fractions. Okay, looking at that, I know that I can never ever divide by 0. So in order to figure out what I need to eliminate from my domain, I'm going to take the denominator and set it equal to 0. That's going to give me x values of positive 3 and negative 2. That's what I cannot equal. I have so many students tell me that my domain is going to equal 3 and negative 2. It is not. That's exactly what I cannot equal. Okay, so if I give you this, how do you write that in interval notation? Well, what you're going to do is you're going to say, okay, look at the lowest number. I'm going to go from negative infinity up to, but not including 2. I'm going to jump over. I have 2 x's I'm eliminating. I'm going to have 3 pieces of my domain. I'm going to go from negative 2 to 3, jump over 3, and go from 3 to infinity. Okay, so that's interval notation right here, and you've got to know this. So maybe we're not going to give you the function, but we will definitely give you either the information of 1x's you cannot equal, or we might give you this instead. Number line, negative 2, positive 3, open circle, your domain is going to look like this. So whether I give you this piece or this piece, you have to be able to get me this piece on this quiz. All right, let's look at the next one. Same idea. I'm not going to give you the function like this, but I will give you the limitations, and then you have to tell me the interval notation. All right, so for this one, it's a radical function. Okay, so radical functions can't have a negative underneath. So therefore, this expression underneath has to be greater than or equal to 0. That means 4 has to be greater than or equal to x. Read it backwards. X has to be less than or equal to 4. Okay, so if I give you this, that's set notation. Can you give it to me in interval notation? If x has to be less than or equal to 4, then that means that that's an ending value, because that's the highest it can be. I am able to equal it, thus the bracket, and I'm starting at negative infinity. So in terms of what I could have shown you on a number line, I could have said this. Okay, here's your 4 right here. I'm going to have a big old closed circle, and if x has to be less than 4, then that means I would have come from this direction first. Okay, so if I give you either this or this, you have to be able to get me back this. Okay, that's on the quiz. Okay, last one on this topic. What if we have this scenario? So look what I have in the denominator. I have radical. Now, I just told you a second ago that you can have a 0 under that radical. However, if that radical is in the denominator, you can never divide by 0. So therefore, our approach is to do the following. Take your t plus 7 and make certain it's going to be not greater than or equal to 0, but greater than 0. That means t has to be greater than negative 7. Okay, so again, it has to be greater than negative 7. Negative 7 is going to be your lowest value. So you're going to start at negative 7. You can't equal it, and go all the way to infinity. So I could give it to you this way, or I could give you a number line. The number line would look like this. Your negative 7. Here's an open circle, and you'd be heading this way. Okay, so again, if I give it to you this way or this way, you have to get me this. Okay, that's on the quiz. Okay, so then we're going to do parent functions next. Now, this is on the quiz, but I'm going to tell you that we're going to do it as a matching exercise. So that means we'll give you the function and the graph, but then you have to match function to graph. Okay, so let's talk about these functions. We're going to create them, and then we'll see where we go from there. So you have to be able to recognize the picture of it. So let's understand where that comes from. Here is it's called an identity function. You know it as a line. Okay, so in this situation, it's called identity because when you put in the x value in your little function machine, you get back the exact same, identical, if you will, y value. All right, so that's going to be your values. And then when we plot this, it's a line that goes through the origin. Okay, so this is what you want to recognize as the identity function. Okay, there you have it. Okay, absolute value. Absolute value, you should think about V for victory. The shape of the graph is going to be a V. And these vertical lines, vertical and V go together, mean absolute value. When you see them, whatever your X value's sign was, you drop the sign. So for example, if my X value was -9, my Y is 9. If it was -4, my Y is 4. 1, 0, 1, 4, 9. Okay, so that's going to start here. You're going to have a line coming out of both sides of the origin. Here is your V for victory. Okay, there you have absolute value function. Think about the V. All right, keep on going down. Squaring function. This function you know pretty well also because you know it as a parabola or a quadratic. Get used to calling it a squaring function. That means that the function squares the X value to get the Y value. If you square a -3, you will never get a negative. Okay, that's -3 times -3, which is +9. -2 times -2, +4. +1, 0, 1, 4, and 9. Okay, plotting that, you should recognize this parent function since you've done a lot of work with that when you were in Algebra 2. Okay, now I'm going to do the last one. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that will be 9. And then connect with a smooth curve. Okay, so it's different than the V function, which was absolute value. The squaring function is a smooth curve, and it's a U shape. Okay, so this is going to be a U shape. Okay, square root function, also called a radical function, but if you think about it as square root, it tells you what to do to the X to get the Y. Again, you cannot have a negative underneath, so we are going to eliminate all of those. You can have a 0. The square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. So when you want to graph this, and we won't require you to graph it right now, but we will later on, you want to pick perfect squares for your X values, because that will give you nice whole numbers to plot, right? So here's a 4, 1, 2, 3, 4, that's going to be a 2, and 4, 5, 6, 7, 8, 9, and that's going to be a 3. So it kind of looks like a flat function. Notice there are no values over here. No values over here because you cannot have a negative under a radical if you are graphing it. Let's look back for a second at the square root function. There are no values down here because when you take the square of something, you never get a negative. So none of the y's will go negative. Okay, so make those observations for yourself. Cubing function. Many students get these two confused. The cubing function, you're going to take your X value and cube it, which means, say, -2 times -2 times -2, which is -8. It does not mean -2 times 3. Okay, so get that one thing straight. When you cube something, if it was negative, it remains negative. And that is totally okay. All right, so when you cube something, you make it the absolute value of it bigger. So therefore, think about this as some kind of a growth function. I'm here, here, and then when I go to 2, it's going to go to 8. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. Okay, there's my 8. And same over here. That's going to go to 1. And then when I have negative 2, I'm going to go to negative 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so look. When you cube something, this function is going to stretch out the value. All right? So it looks like it's growing. It's either growing positively or growing negatively. As opposed to a cube root. When you take the x value and you take the cube root of it, you will always, forever and ever, make it smaller. Okay, so this is what we have. So what's that going to look like? It's not going to be growing. It's going to be pulling horizontally because things are getting smaller. So look, interestingly enough, those first 3 values are exactly the same on the cube root function and on the cubing function. What really explains it is when you get to a bigger value. So look at 8. So 1, 2, 3, 4, 5, 6, 7, 8. That's going to pull it the direction I want to go. 1, 2, 3, 4, 5, 6, 7, 8. And that's going to be down here. Okay, so this is the function. It's coming this way. So compare that to the cubing function. Cube root, you make the numbers smaller. Cubing, you make them bigger. The numbers that you're making bigger and smaller are on the y-axis. So therefore, cubing is going to pull it up. Cube rooting is going to pull it down. Okay, you're stretching it east and west. All right, that's the end. So, things to know. You want to be able to know the name of the function and match it to its graph. Okay, so you can try to plot a few points if you want to kind of figure it out, but it's a matching event. Everything I talked to you about on this video is on that quiz. Other things on the quiz. You've got to know all the lines. You've got to be able to put an equation into the form we tell you, and we're going to use a lot of point slope. You have to know how to deal with perpendicular lines and parallel lines. You have to know how to go between forms. So you've got 3 forms of a line. Point slope, y equals mx plus b, which is slope intercept, and standard form. You've got to know and be able to manipulate all of these forms. So watch the video I did on lines. It will give you a lot of good hints as to what you have to be very, very good at in order to be successful on this coming quiz. Okay, so that ends this video. I hope you found this helpful.